the last part of our video for chapter 4. In this video, we're going to look at a couple of examples. I'm going to look at the example of how to work with Minitab to test hypotheses. And we're going to look at the example where we actually have summary information, means no detailed data. And then the second example is something we looked at before when we looked at confidence intervals. That was about the commuting times in San Diego. And for that one, we're actually going to have data. So we're going to look at both modes of running the hypothesis tests in Minitab. So here I have the example. Example 1, a company manufactures and assembles desks and other office equipment at several plants. The weekly production of these follow a normal distribution with a mean of 200 and a deviation of 16. Recently, due to market expansion, new production methods have been introduced and new employees hired. The VP of manufacturing would like to investigate whether there has been a change in the weekly production of desks and other office equipment. And we're going to use alpha 05, 5% significance level, to test this hypothesis. The average number of desks produced in 50-week period was 203.5. Okay, so we are given that. And with having told a 50-week period, that indirectly gives us the sample size. So, now as far as the statement of the hypothesis, because I have it highlighted here, because we are interested in knowing whether there has been a change. Notice it doesn't indicate whether the change is greater than or less than in production. Has it increased or decreased? Has there been a change? So the null hypothesis is going to say that it hasn't been changed, it's the same as before. And the alternative actually is going to be a two-sided alternative. Again, because there's no direction in that phrase, there has been a change. So what I did is in Minitab, I ran a one sample Z hypothesis tests. And the hypothesis test is actually down here. See right in here, that's the test. It gives you the confidence interval also, which is good. I'm going to make a comment about that, and that might again help you with your midterm question, one of them. So it looks like this is a two-tailed alternative. So this is how symbolically you actually write this hypothesis. Mu is equal to 200 versus the alternative that is not equal to 200. Okay, now look at our p-value right away. The p-value is 0.382, which is pretty large. And this z-value that you see in here, what is this number? This is the value of test statistic. It comes from a formula, which I didn't even show because we're not going to do this by hand in this course anyhow. But that's what that is. That's our test statistic. So we're just going to use p-value method of doing this. Remember, if p-value is less than or equal alpha, the size of our test, we're going to reject the null. Now, in this case, p-value is 0.382, and that number is not less than 0.05, right? The significance level was 5%, and it's right up there. See, it's right here. And because it's not less than that, we fail to reject the null hypothesis. Now, some say we accept the null hypothesis, but since everything is based on data, I think it's better to say we fail to reject, because the fact that we say we fail to reject, it doesn't mean we have committed to the null. Maybe a different sample would be able to reject it. It's just this one was not able to do it. So for that reason, we use the phrase you fail to reject the null. Okay. And let me erase these. Okay. And now here's something cool, folks. We can actually test a hypothesis using a confidence interval. it does require that it has to be a two-tailed test of hypothesis, okay? Which in this case, it is a two-tailed test of hypothesis, right? Right in here, you see that? Not equal to is two-tailed. So if the alternative is two-tailed, and also your confidence level here should match your alpha. Alpha must be 0.5 because your 1 minus alpha is 0.95. So it's not like I can do a 95% confidence level and an alpha 0.01. They have to match, okay? They should add up to 1, those two numbers. So, and that's what I have down here. You can test the hypothesis using confidence interval also. Now, provided the significance level, that's alpha, is alpha, and the test is a two-tailed test, and the confidence level must be 1 minus alpha. So, make a long story short, based on what I see here. Remember, the hypothesized mean is 200 right here. And that 200 is actually inside of that confidence interval, isn't it? So if it's in the confidence interval, we don't reject a null. So you can actually test a whole series of numbers here, couldn't we? For example, if I want to test the null hypothesis, that mu is 205. Well, let's see. 205 is in there, so I do not reject that null. What about mu 210? See, I can test that also. 210 is in there. We don't reject that either. So you get a whole range of hypothesized value that you can actually use. Okay. So let me erase these, make him look clean. And then we'll look at our next example here. All right. So there you have it. And I'll go in StatCrunch and in Minitab and show you how this is done in a minute. So here in yellow highlight I have, because 200 lies inside of that confidence interval, remember 200 must be the hypothesized mean. If it's inside the confidence interval, you don't reject it. If it falls outside, you reject the hypothesis. This example we actually saw earlier when we looked at confidence intervals. So remember, this is an example where we want to look at the commuting times, one-way commuting times. So that's what this is. So we're familiar with this example. Now, if we want to test the hypothesis here, right, I'm down here. We want to test the hypothesis that the average commuting time in the city of San Diego exceeds 30 minutes. And we're going to use alpha 0.5 significance level to test the hypothesis. So with this one, we actually had data. Now here's the statement of the hypothesis. We want to actually test the hypothesis that, let me choose this one. See, this is the alternative. Here we are interested in knowing whether the average time exceeds 30 minutes. See, exceeds means greater than. The alternative is greater than. That means the null must be less than or equal to complement it. So this is a right tail test. And being a right tail test, I ran it as a right tail test. And here's the statement of the hypothesis, the null and the alternative, and check out that p-value. Wow, 0.997, very large. So for this one, we actually we will not be able to reject this null, right? So I'm just going to write it, since my p-value of 0.997 is not less than or equal to 0.05. Again, we fail to reject this null. Remember, the null said, nah, if anything, the average is less than 30 minutes commuting time. So we were not able to reject it. And look at the sample mean, by the way, it showed 26 minutes. Okay, which is less than 30 minutes. So the researcher did not gather evidence against that null. Now, something interesting just to touch up on this one. Notice for confidence interval, usually we have a lower limit and we have an upper limit, right? LL, lower limit, upper limit. This one, because the alternative is greater than, this is what Minitab has done, is actually done a one-sided confidence interval. And it gives you 95% lower bound for the mean, which is 24.33 minutes. So this is actually what the confidence interval looks like. There is no upper bound because of greater than. Okay, so just want to point that out, because again, Minitab actually gives you that, so that's why I want to touch up on that. And let me clear these out, and we'll keep everything else here. All right, so let's go ahead and try to run these, both of these in Minitab. Okay, the first example and the second example. Remember, for the first example we had summary data, and in the second example we actually had raw data. We had actual numbers for this. Okay, and let me do that. I'm gonna go ahead and go to Minitab and to finish this off. So I've got Minitab up and running. Now, because, let me actually clear these, because I just ran them to put them in my notebook. Let me clean the slate, so to speak, and I can recreate these. All right. Now, this is the data for second example. Remember, we actually had this one from earlier confidence interval. So let's run this one with data. So here's where we go to do a hypothesis test. We're going to go to basic stats. And remember, we've been to one sample Z before. You go there to do confidence interval and hypothesis test. Okay. Now for this one, let's see, we're doing the second example. So for this one, let me clean that. And these numbers we actually have, you can type these in from the example. The deviation was 5.124, and click inside of this field and double click to bring the variable time as a column variable into that field. And make sure you perform the hypothesis, and you just type in the hypothesized value 30 here. We then go to options, and in here, if you click there, you have the three options: left tail, two tail, right tail test. In exercise or example number 2, we're doing a right tail test. That means it's greater than. Hit OK, and we're good to go. And there you have it. So this is the output that I got. And of course, you can import it into Word. You can copy it and paste it and what have you. Okay. So there you go. That's exactly what I had in my notebook. Now let's do our first example where we had summary data. You go to Stat, Basic Statistics, one sample Z. And this time, see, I'm clicking right here on top. Choose Summarize Data. Our first example had summary data. Now, again, because I ran this example earlier, that's why you see these fields already populated. Let me remove them. So this is what yours should look like, correct? So we are using Summarize Data. The question reads, what's the sample size? Remember, this is example 1. Sample size was 50. What was the sample mean in example 1? The mean was 203.5, and the standard deviation was 16. And we're going to do a hypothesis test. What is the hypothesized mean? It was 200. Then we go to options to choose our alternative. And for this example, the alternative was a two-sided alternative, two-tail test. And because it's two-tail, you can actually keep that at 95, OK, and hit OK, and there you go. This is what I got for the first example. So pretty easy, simple. And again, we had to go through all those jargons, terminologies for the last few hours just so we can understand this output. So we know what p-value is, what z-value is, and what are these doing for us. Okay, and for this one again, p-value is large. We're going to fail to reject a null. Now, one last comment here. We failed to reject a null because we didn't have sufficient evidence, right? Well, the null could still be false, couldn't it? The fact that the null could be false and we did not reject it looks like we have committed a type 2 error. We did not reject the null and we should have. So there is a probability associated with that which we could measure, but again, we're not covered that in this course. So there you have it. Hopefully that was easy to do. Let me go back to my notebook, and I think with that we are done with this week's lecture. You should be able to do your midterm as well as your homework as it pertains to Chapter 4, Confidence Interval and Hypothesis Test for 1 Population Mean Mu.